Hey everyone, thanks for coming to the talk. I'm Gautam, and this talk is mostly about the cross-cloud kill chain. Like right now, we have different clouds, and all the companies use multi-cloud strategy. So as a defender, how do we defend it? So how do we write detections and where to focus? Because you can focus on AWS, you can focus on Azure GCP, but what's the pain point and where is the blind side? So that's what I'm going to focus on. A bit intro about myself. I work at Meta as a threat detection engineer. I graduated from CMU like a couple of years ago, and I have some couple of certifications. Like it's mostly on offensive security. I use that to support my defense, because you have to know what the attackers do. You have to understand it to write efficient detections. And I have gotten a couple of CVs, and I write blogs in Medium. Occasionally, I'm trying to get back to it. And my interest, I play badminton and NBA with my friends, like whenever I get time during Friday nights. And now to the fun stuff. Before I get started, I want to make a statement saying like the cloud mental model that we have is a convenient fiction, because when you think about it, 10 years back when the cloud came into the picture, we all thought like, okay, when someone says cloud, it's either AWS, Azure, GCP, but is it still the same? Are we still using AWS for everything, or is the companies moving towards multi-cloud strategy? You might have seen companies now use AWS for all the instance, having S3 buckets, but they use GCP for doing more data-based workloads, right? And Azure for identity management. So it's convenient for the companies to use multi-cloud strategy. And data from Flexera says 89% of their customers use multi-cloud strategy. That's a big number, and it's just gonna go up. Not everyone gonna use just AWS for their use case. And as a defender, what does it matter to us? Because it matters to the attackers and how they see the cloud as a single entity and not just AWS or GCP. Because when they build their kill chain, they're gonna use all the misconfigs between the gaps, between the trust that we build for the business use case, and abuse the identities. And here's their advantage. The environment is complex. We have multi-cloud, and Gartner says 99% of the incidents that happen in the cloud is due to the customer faults. Yeah, it's on us, on the security partitioners, to take care of it. It's all misconfigs, right? Because we are not perfect, like we make mistakes. And this complexity leads to the number one attack vector is compromised credentials. Because when we talk about cloud, we are not just saying it's the 0 days someone is getting access to. It's mostly an abuse of misconfig compromised credentials, using which attackers get into the network. And once they get into it, what they're gonna do if you have a multi-cloud strategy, they're gonna abuse the trust relationship you build, trusting Azure from AWS, or from AWS you're trusting Azure, so they're gonna abuse it, and it's not gonna be a good day for us. And they thrive in those gaps, and our security team, we just have security team for AWS, Azure, GCP, building detection just for AWS, building detections for just GCP. It's not gonna hold good. And one example is, as an expert in AWS IAM, they may not see the risky sign-in from Entra ID, and that's bad. So what's the solution? So for these, this is the action plan I propose. You map the trust to see the true attack surface. This is going to be the hardest part, right? Because it's a messed up environment. You have a lot of trust going in, you have a lot of connections, but once you get it ready, once you know which is trusting what, you make the graph, then the next thing is you have to develop the logs, because no logs, no detection, nothing. So you have to unify the log, build cross-cloud visibility. And once you have the log, is that enough? No, because the unparsed log is not good. So we have to enrich it with context. Example is, if a user, we have the user ID, we have to know which department, which role, and we have to analyze the user. And if they're accessing a resource, we have to know the context of the resource, which group of users have access to it. And the fourth one is building the high fidelity correlation rules. This comes from the nature of the surface, because we are focusing on the cross-cloud, so we have to build a high fidelity correlated rules, else it's really hard to make an actionable response to it, because if you get 1,000 alerts per day or 2,000 alerts per day, can you actually triage it? Yeah, we can use LLM to triage it, but will they hallucinate? We don't know. And the fifth one is automate the response. So as much as possible, you have to automate the response. Else it falls on the investigators to investigate it, and it creates alert fatigue. And the sixth one is get the feedback and improve it. This is the plan, but how do I implement? Is there an example? So we have story time. And in this, I have put up attack, like an example through the real world scenarios. So as you see on the right, these are all the breaches that inspired me to create this chain. So where it starts from the developer phishing a creds and hijacking the session, getting into Azure, from there moving to AWS, and from there to GCP. So this shows us how a simple phishing can be a nightmare, multi-cloud nightmare to a incident response team, and how as a defender we're going to defend it. To know and to defend, we have to know how the offense happened. So it's going to be two sections. First, we focus on the offense playbook and understand how the attack happens. And the next, we're going to see how we defend it and how we scale to your environment. First thing, the initial access, the crucial one, the phishing. Attackers, they send SMS to the developer saying, hey, you have to re-auth. You might think, I'm not going to fall for it, but just think we have a lot of developers coming from different backgrounds, living different lives, so someone clicks on it, and they enter the credentials and MFA. What the attackers are going to do, they have a reverse proxy, man in the middle. So it's called the adversary in the middle. So they capture the credentials with the MFA, and they get their session. As you see, in the step 5, they have creds and the session, and they log in to your Azure, or in this case, the company's Azure account, like the Entra ID. And once they log in with a different Tor node, may not be the case, they can use VPN, they don't have to use Tor, but they have to hide their IP, because what's the easiest way to block someone is through IP, that we know from the TTPs pain, the pyramid of pain. IPs are easy to block. This grants them access to the Azure, but we got an alert, right? That's good, but what do? We get these alerts 1,000 times, million times a day, but what is the actionable insight that we do? We don't do anything. It just stays in our environment. It says anonymous IP address sign in, but we don't take any action. So it's as good as no alerts. And what the second stage, what the attacker does now is, they are moving from Azure to AWS. So this is the fun part. We are using Entra ID for SSO, and in the My Apps, they have AWS, and you might have this in your org, where you use SSO, from there you have GCP AWS access. What does it mean? It means they trust SSO, they trust Entra ID as the IDP, and it provides the service, right? And in this case, the service is the AWS. So they use the AWS sign-on app, they click on it, it gives them the SAML assertion. So what now? The attacker passed the SAML assertion to the AWS. That grants them a temporary token. It's as good as a credential into the AWS account. Now they have access to AWS from Azure's infra or Entra ID. So here, it's not a vulnerability. It's more of a feature that we build for business convenience, and they exploited that to move around. What do they do next? From AWS to GCP. So this particular step, this was inspiring while I was reading some blogs about how TF state file have private keys and attackers see it in S3 buckets. It may not be public, but once they have access to AWS, they can enumerate the S3 buckets, right? And they see a GCP prod TF state. It has all the private keys, which gives them access to GCP. And once they use the service account stolen key, they are accessing GCP, and you know how Terraform works, right? So if you want to create infra and we have all the critical, sensitive, private keys stored, that means they have unlimited access to GCP prod, because any automation requires creating multiple resources, and the admin could have created with a very lenient permissions. So they got access to all the GCP projects. That's the worst that could happen. So attacker is on GCP. Started with Entra ID Azure, AWS, now to GCP. Simple thing, right? What's the end game? How does it look like? So because if I don't talk about the end game, that's what the attacker is there for. First one is exfiltration. The first one is they can exfiltrate from Azure to GCP. And why is it different from directly taking it out of Azure blob? You might have a detection just for Azure saying if someone exfiltrates out to the internet from Azure, catch that, alert it. But don't we trust our internal connections, or don't we trust all the cross-cloud that we build? We allow list it because we see a lot of alerts, so it's easy to reduce the alert. So we allow list anything from Azure going to GCP. So that's a blind spot. So they take it to GCP, and from there, they might find a blind spot to download it to their local computer. And the second one is the persistence. So they can use assume role permission to create a new IAM user for persistence, or they can also create service account for persistence. Now, this is the depressing part, right? So how do we as a defender going to defend the same actions? And when we are defending, it's not about whether we defend or whether we don't. It's more of how fast we defend. If the more they stay in our infra, the more bad it is, the more loss for the company, and more questions for us as the defenders. First and foremost important thing is the visibility. We don't detect what we don't collect. So the more logs we have, the better it is. First, we have to centralize our logs. Why do we have to centralize it? Is it okay if it's in different buckets? Yeah, it's okay, but if you can centralize it, it becomes easy to run all the detections, because now it doesn't have to go to AWS, GCP, Azure in a different data lake, pulling all those data from infra, and it creates latency. So if you have a lot of data, having it in one data lake will be easy. Example for us here is from AWS, we need CloudTrail to detect the attacks we have seen. We need Entra ID logs, sign-in audit logs. We need the cloud audit log from GCP as well. Once you get the logs, what next? Those are raw, unparsed logs. What's next? Like, we have to normalize it, because what ends up happening is we might write a big detection or confusing detection or a lot of detections to parse it. So it's best to use OCSF to normalize it, to translate it into a common language, and map everything in OCSF. Example is AWS we see assume role, and in Azure we see sign in. Both can be considered as an authentication log, and we can map it in OCSF. The second is the art of writing detection and enrichment. Now we have logs, we see risky sign-on, but that's a noise, that's an event. But to create a detection, we need different events combine together to create a scenario. In this, we hunt for the scenarios, not the isolated logs. And what about enrichment? So now you have an alert saying user ID 1569 has accessed S3. Is that good enough? No. Now we have to know which department the user is in, and is that a service account or a user account? So we go to the HR, ask them like, okay, this user belongs to which department and where do they stay? What's their country? That gives us more info, the context. That's where we use it to close all the IOs. I've seen it, the context of the user helps a lot. And what resource was touched? Now you know the user, now you have to also enrich it for the resource. So we say whether it's a prod database or whether they touched any S3 which is critical or it's just publicly available. That helps us close. So as you see, the example is user X accessed file Y, which is a high priority finding. No, we don't want to see like a junior engineer from the marketing department just accessed the prod CRED files in Terraform. So once you enrich it, that gives you the story of what happened. And the last piece is thread intel. This is going to be useful. You have IP, you have domains, you know where it's going. We can associate with threat actors. So that tells us, okay, this is going to an IP or a domain that we think is bad, gives more weightage to the investigation. Some samples. So now it's detection time. First detection, correlating the cross-cloud pivot. So the logic here is finding a high-risky user from Azure who logs in and assumes a role in AWS. What are the triggers? Because we want a high fidelity detection, we want to correlate. What are some triggers? In Azure, we want the log saying it's a risky user who is using the application AWS. And in the AWS, we want an event for assume role with SAML or assume role. And we get it from the CloudTrail. And what is the condition? The user principal should be same. And if it happens within 15 minutes or an hour from the same IP, we want to alert. And this is a high confidence detection because it's not only looking for sign-in, high-risk sign-in, it's also looking for assume role, which means in AWS, which means they accessed AWS. And from the same IP within 15 minutes. So that's something bad. We can also couple it with other scenarios based on your infra. For example, they are accessing S3 or DB. They're enumerating. So imagination is the limit here. And some KQL. For people who like reading KQL, as you see from line 1 to 4, we have the risky sign-on, so we get it into the variable risky Azure logins, and we have assume role with SAML as the second line from 5 to 8, and in line 10, we are joining it based on the IP, username, and within 5 minutes, and we output it like. This is just a template. You can edit it, but this gives you an idea of how it would look. Once you use OCSF, it's going to get even more simpler. And the TTP2 is anonymous service account key usage. This one, and user is logging in via federation from AWS, and they are through Azure or Entra ID. And in AWS, they are searching for Terraform. Could it be just Terraform? It could be anything based on your infra. If you're using Terraform, let it be Terraform. If you have any financial files, let it be CSV. You can add those financial file names. We have LLM. We can use it to see whether the file name or things they are accessing is critical, but you have to fine tune it with the prompt. It's more on prompt engineering. And what's the first trigger? In the CloudTrail, we see the user accessed via federated event, assume role with SAML, same as the previous detection. Trigger to CloudTrail. In this, we see they are accessing S3 bucket because we see get object, right? So they are accessing S3 or any apps in any service in AWS. You can have it as trigger to. And the condition is when they access the key, it ends with .tf state, and it contains, because that contains a critical file, So that's one of the high fidelity alert we want in this case. But based on your infra, it could be once they access the key, they're going to GCP now. They're accessing something using the TF state file they acquired, and they're accessing any of the services in the file in the GCP. So that could be one of a detection in your infra. This is how the KQL looks. So we have assume role with SAML from CloudTrail. So that's the federated logins. The second part we want is get objects from S3 bucket that ends with TF state. And we have to join it. That's where the correlation happens. High fidelity comes based on the user ARN within 15 minutes time bucket of login. And third detection is not a rule-based. This is more on baselining, because I was researching on baselining and this sounded fun, so I wanted to bring some ideas on how you could baseline the cross-cloud activity. Let's say we want to find a user who deviates from the normal activity. So what's a normal activity? That's where the baseline comes. You have to say, what's a normal day look like for that user or the group of users? What do they access? What kind of sources, databases, S3 buckets they access daily? And what do they do once they access? Do they edit it? Do they look at it? Do they move it? And how does the logic look like? So let's take an example. Developer Z at company.com, they authenticated, they go to the S3 bucket, but we have to check now whether have they actually accessed the S3 bucket before, or any of the S3 buckets in the group, or the user coming from a particular developers group, are they accessing that resource? So this creates a baseline. If the logic says they have never accessed it, then that's a rare find, so we alert it. And we have to determine if the S3 bucket or something they're accessing is sensitive, because in our infra, people access different things, people deviate, people get into different project deviate, but we have to determine the criticality of the things they are accessing and criticality of the credentials the user has to know which is bad and which is sensitive. And once that's done, then we flag it as suspicious, and that's a powerful lateral movement and credential abuse baselining detections. We could use ML or any models to get done with this. And the step 3 in defenders is the response, identity-centric response. And why do I say automator again and again? As I talked before, it helps the investigators. The more context you could pull, the more automation you could do, the investigators gonna love it because it helps them. They don't have to spend a lot of time running a query, searching through the infra to connect the dots. As much as we give, it helps them. So for a response, we need a trigger. That's the alert. High fidelity alert. For example, like here, high-risk user, sign in from Azure to AWS. Second, enrichment. So we have the user. Now, in AWS, we can use Graph API and get more details about the user. We have HR or HR DBs, any HR platforms. And also, we can get what IAM permissions they have and which are all critical. So here we can use LLM to say which are all critical, or we can use a mapping file. And what's the third step? So this is critical to reduce noises. False positive check. You might have seen a particular group of users always continuously accessing something, which means like you either would have allow listed the group of users, or you have to use some logic to close the IO here, close the alert here. If we don't close the alert here, it creates a noise. So it's critical to always check for any false positive and close it. One example here is DevOps user going from AWS to GCP for cross-cloud deployment. We close it. And containment or kill switch. So we have to pull the plug here if we find something to be bad. So how do we do it? In Azure, we can use revoke sign-in sessions to revoke their sessions. Or in AWS, we can invalidate all the tokens happened previously for the user, so that any login happening after that through the federation will be valid, but anything happened before, it's not validated. So now we have the response, we have closed the false positive, we also have the kill switch pulled out. So what's the final step? We have to get people in, to investigate, to give the feedback, or to move further and investigate furthermore, because these are all automation, right? We create Jira service now with the context as much as possible, so they can close it or they can investigate it. And also, it's better to pull all of them in a group, either Slack or whatever internally you used for messaging, so that they can chat about it, they can close it faster. If you don't create that environment, it will be hard. How many people just keep on gonna look at the Jira tickets? It's hard, right? And how do you scale to your environment? So we have talked about an attack. We know how the attack happens. We know how to defend it. So how are we going to apply this? How are we going to scale this? So first is map a trust relationship. That's probably the hardest one. Example here, we have Jenkins CI/CD in GCP. So that has service account key that's going to AWS and deploying some code. That's the trust we find. And the second thing is how someone can abuse the trust. So we have Jenkins. We have seen a lot of CVEs, Jenkins being compromised. So someone abuses the Jenkins, compromise it. What's the next thing? They get the GCP credentials or GCP service account token. So once they have the key, then they go to the AWS. So that's the abuse scenario we have formed. Once you have the abuse scenario, we can write the detection. The detection is like assume role in AWS, follow with the Jenkins principal and GCP going to GCP, from GCP to AWS, sorry. And that's doing something bad. So because just from GCP to AWS is not bad, but doing something on the AWS is where we want to correlate to. Here we can have update assume role policy. So they're updating some of the role policies. Why do they have to do it? They want to have persistence, they're doing it. So this is where so now we have defined the logic. Once you have the logic, is that enough? Because you're gonna get alerts. So how do you gonna investigate? Any alert that's not investigatable isn't really useful. So we have to create Playbook for the investigators to come in, investigate it, and close the IOs. So we also have to have a containment plan. That's sometimes optional. Sometimes we want to look at the IO or the workflow or the runbook before we close it. Sometimes you want to click a button and disable all the GCP service account or any of the AWS role. We want to revert it. So it's completely optional based on preferences, based on the scale of your infra. And yeah, that's it. Thank you so much for attending the presentation, and I'm happy to take any questions.